Okay, so let me just make some corrections regarding our use of the Nernst equation in our video number 1 and video number 3. Video number 2 is already okay, so no corrections there. So we have to go back into our Nernst equation. If you notice carefully in our videos, there were some inconsistencies in what I plugged in sa loob ng ating ln. So it should be na it's rad over ox. So the rad stands for the reduced form raised to the exponent b. The exponent b is whatever is the coefficient ng ating given a species from the table. All over ox raised to power of a. A is the coefficient of the oxidized species. Now, let's going back to the pre-equivalence point. We have the following. As we've noted in our first video, we have here the following equation from table C.5. We noted that since this is pre-equivalence point, there is a lot more of the vanadium present than the tin present. So if we're now going to plug in the values to our Nernst equation, using the values we have, E0 is negative 0.255 volts. We should be able to get the following. So we should have written instead this E equals to negative 0.255 minus 8.314 times 298 all over the number of electrons. There's only one electron, so I just write 1 times 96,485 ln, the reduced form. Ito ang reduced form natin. The one that is listed on the right side ng ating half reaction listed on the table. So for vanadium 2, we already took note last time. Our concentration for vanadium 2 plus is 0.067 molar. Divided by the concentration of the oxidized species or the oxidized form, which is this one, yung nasa left side ng half reaction from what we've listed on the table. Vanadium 3, as you can see, only has a coefficient of 1. So, we just simply write in here, divide by 0.017 molar. So, plugging in the values now. So, I should have gotten instead an E equal to negative 0.291 volts. So, same issue rin siya with our post-equivalence point. At the post-equivalence point, as we've noted, what is in excess is already actually our tin 4 titrant. So, I'm writing now what we have looked up in our table C.5. So, E0 here is 0.154 volts. Again in here, the reduced form is the one on the right side. And the oxidized form, that is the one on the right. So when using the Nernst equation, I should have inputted instead the following. So I have 0.154 minus 8.314 times 298 all over the n. The n here comes from the number of electrons that I got from table C.5. So that's 2 electrons times 96, 485. Ln, the concentration of our reduced form. So that is equal to 5 times 10 to the negative 5 molar. Oops, sorry again for that one. For the reduced form, that's actually the tin 2. So the tin 2 has a concentration of 0.025 molar. Divided by the concentration of the oxidized form. The oxidized form, we've computed it already in our third video. That's 5 times 10 to the negative 5 molar. So plugging in the values now to our calculator, I should have gotten E here equal to 0.074 volts. So that's our key when using the Nernst equation. Remember, it's always going to be the reduced form divided by the oxidized form. Reduced, kung sino mas maliit ang oxidation number, divided by the oxidized form, kung sino yung mas malaki ang ating oxidation number.